Hey folks, welcome to another episode of the MakeCode Arcade Advanced stream. We're the devs on the MakeCode team. I'm Richard, at Richard on the forum.
I'm Shannon. I'm at Shakao on the forums.
I'm Daryl. I'm at Darzu on the forums.
And I'm Joey. I'm at J1Daryl on the forums.
I'm sure anyone who's used our forums has seen Joey all over them. He is still the #1 likes receiver on our forum, but coming for that title, Joey. So what are we doing today, guys? I mean, streaming arcade, of course, but like, what's the plan?
So we've been making new games with each stream. And with this one, I think we thought we would take an existing game and see if we could mod it.
Yep. And the game we've chosen this time is the first game ever made in MakeCode Arcade, which is Falling Duck. This is actually not the first version. There was a first version, but I couldn't find it, so we're just gonna play this one. So if anyone's come to the MakeCode home screen, they've probably seen our duck before, and they've probably seen this game. But let's go ahead and go full screen for a second, and I'll just kind of show what's going on in this game, and we'll talk about the mechanics and then walk through the code. And then we're going to brainstorm some ideas on how we can improve it, and we're going to, remix it and make it our own game. So let's get started. All right. Falling Duck is a pretty simple game. You have a duck, and when you flap, you move upwards. You flap by pressing the A button, and you're trying to go in between these gates. Every time you go through a gate, you get a point, and you just go for as long as you can survive.
Richard is making this look very easy. I assure you, it is not.
I am the high score holder for the team, I think.
I think so.
Yeah. So let's just kind of break it down and see how this is actually working, right? So we have our player sprite. It has gravity, the duck. When you press A, the duck is flapping and also creating some particle effects, the little bubbles that are coming out. And then we also have these gates that are creating, and they're moving from the right side of the screen to the left. So it looks like the duck is actually moving from left to right in here, but that's actually just a little trick that we're playing. It's actually the gates that are moving, and the duck is staying still in the X direction.
Mm-hmm.
Okay, so now that we've taken a look at what the game is, let's break down the code and kind of go through that. You were saying something, Daryl?
It looks like the gates are in many different positions too, so that's kind of interesting.
Yep. So there are 4 different type of gates that can appear. There's up here, like towards the middle from the other direction, and then down at the bottom. All right. So this might look like a lot of code, but it's actually pretty simple. We'll just walk through it real quick, and hopefully we can come up with some ideas in the process for what we want to do to expand this game. So let's start where the game starts, in the on start. And the first thing we're doing is setting the background color, the 0, and we're starting this screen effect. That's just, our boilerplate initialization stuff. Then we're creating the player sprite, which is the duck. We're giving it gravity, which we're setting to 300. What unit is the gravity in, Joey?
Pixels per second per second.
Yeah. So normally when we talk about gravity, we talk about usually meters per second, but all of our units in MakeCode are based off of pixels. So if you use the velocity, you're setting pixels per second, and if you set the acceleration, you're doing pixels per second.
Quick question. You said earlier that we were creating or setting boilerplate. What does boilerplate mean?
So boilerplate code is just the code that you kind of always have at the initialization of something. So a lot of times, depending on the type of project that you have, the boilerplate code would just be like something that pretty much makes its way into every single game that you make. So in this case, we're setting the background color, we're setting the score to 0. Those are things that happen in a lot of different games, which is why I referred to it as boilerplate. Is that the definition you were looking for? Do you have a better one?
I actually don't know the origin of that, but yeah, that's what I was thinking.
All right, awesome. Okay, so next we're creating an animation. So this is using our old animation APIs, but I'm going to go through it anyway just to explain what's going on. We're creating an animation and we're giving this title of jumping. And the interval is how much time is in between each frame. Then we're defining all of our frames. So you can see we have duck going through the various stages of flapping. And then we attach the animation to my sprite. So this is just creating the animation. It's not actually running it. The running happens over here in the on any button press. So Falling Duck is a one-button game. You can press any button and it'll do the same thing, except for menu, I think. So when we're pressing the button, the behavior that we're getting is that our duck is flapping its wings and also going up a little bit. And the way that we achieve that is by setting the velocity to a negative value. If you remember, in MakeCode, the y direction goes down for positive. So when you set it to negative, that's making it go up. It's a little backwards from what you usually learn in like math class. We're also activating the animation, which is causing the duck to flap its wings, and we're starting this particle effect rings. Okay, so we've got the flapping and we've got the creating of the player. Let's talk now about the gates. Does that sound good?
Sounds great.
Okay, here's definitely the most complicated part of the code. So we're trying to create one of 4 different types of gates. There is the high gate, the not so high gate, the even lower gate, and the very low gate, if that makes sense. Just 4 different positions on the screen. And so to determine which gate that we want to create, we first pick a random number from 0 to 3. So you might think we would go 0 to 4 because there's 4 different kinds, but 0 is included here. So our possible options for this number are 0, 1, 2, and 3. Then we're going through all the different possibilities for the gap, and we're setting our images. So there are 2 images here. There's the top side of the gate and the bottom side of the gate. And they're both gonna be moving towards the duck. And so the way that we can make different sizes of or different positions of the gate is by swapping out the images that we use. And that's what's going on here. So if we look real quick, we can see that this one is just like the top of the gate. This one is the bottom of the gate. It's much longer because this is the gate that is positioned highest up at the top. All right. Once we create this image, we're also creating what we call the gap. So the gap image is what we're going to be using to move the whole thing together. We draw both of our images, the top image and the bottom. Oh, sorry. I'm reading this code wrong. Okay. So we create a gap image so that we know when we've passed through the gate. So this is an invisible sprite. Let me actually make it visible first, and we'll be able to see where it is. So you see that white line that appears in our gates? That is what we're using to keep track of the points. So when you hit that white line, that's when your score goes from 0 to 1 to 2 to 3 to 4. But we don't want the player to see that. We're just using that for the collisions. So we can actually turn that back to on, so it's invisible again. All right, and then finally, this code down here is creating the 2 projectiles, the 2 sides of the gate, and also the gap, and making them move across the screen. So like I said, our duck is not actually moving X or Y in the X direction. It's moving in the Y direction. So if I were to set this to 0, this 2, and this, and now I play the game. Yeah, I gotta admit, that's a pretty unexpected result. I don't actually know why that's happening.
Let's see. Oh, I think it's
right. We have
from side, projectile from.
Yeah. Okay, let's just pretend I didn't do that. So the top image we're setting to be at the top of the screen, so we're setting the top to 0. And for the bottom image, we're setting the bottom to the screen height, which will put it at the bottom of our screen. All right. So that's the gate creating. We're not quite done yet, though. there are a few other things left in this program. So let's first go with our overlaps. So like I said before, we're going to change the score whenever we overlap the sprite of kind gap. So that is our white sprite that is changing our score. We have a little if statement here, and that if statement is checking to see if we are past the gap or not. So if we don't have this if statement, then every single time we overlapped with the gap, well, one, our scoring would look a little weird. We would get points before we actually enter into the gate. But the other thing that's nice is this will make it so that we only change the score once. Our gap is 2 pixels wide, so when we move past it, this will only trigger the score once instead of twice. All right. We also have this overlap event. So this time it's between the player and the projectile. So the projectiles in this case are our gates, the top and bottom half. When we overlap with those, we trigger a game over and the game ends. And there is just one last piece of code. Thanks for sticking with me, everybody. And that is on game update. If the velocity is set to 0, then we want to stop our flapping animation. And so we're just activating this idle. And all that does is turn off all animations, basically, because we haven't defined an idle animation. And then this one right here handles if our player has moved too high or too low. So this was something I didn't cover when I was playing the game before. But if you go up into the sky and you hit the top, you will lose. Same thing if you hit the bottom, you'll lose. And so this is just checking that. If my sprite bottom is greater than 120, that's the height of the screen. In fact, I'm going to change that real quick just to make it a little more explicit. Change it to screen height. Or if the top is less than 0, then we've got a game over. All right. Any questions? I think that pretty much covers the code. I know you guys are all familiar with this, but for the sake of the stream.
So one thing I think is a little bit interesting is how you're saying my sprite, if the velocity is greater than 0, set the idle. So a negative velocity means you're going up. So anytime the duck's going down, then you stop the animation. So even if the animation were to naturally play for a longer duration than it would take to go up and then down, it will still stop it.
Yep. And so you'll actually see sometimes the animation will end on different frames when I start going down. That's kind of a byproduct of this.
Right.
Okay, so before we get started, I'm just going to make this a little less visually busy, and I'm going to remove the particle effects. Does that sound good to everybody?
Yes.
All right. Going to get rid of the blizzard, and I'm also going to get rid of that ring animation we had.
I think it's top middle.
Top middle.
There we go.
Button pressed. Any button pressed. Yeah.
Ah, yes. I was looking for the same color as the scene block. All right. So this is a pretty fun game all on its own. But let's come up with some ideas to how to make it our own and maybe make it a little easier. So we've gotten feedback that this game is difficult for, it takes a little while to get the knack of it. So any ideas?
What if you had a trail of baby ducks following you, and then if you run into a log, then one of them, you become the next baby duck.
Okay, so it sounds like you're talking about multiple lives.
Yeah.
And I'm going to make one addendum to that just to save myself from having to animate baby ducks, which is...
Oh, yeah.
Oh, yes.
And
can they be eggs with wings?
Get lives too. I guess you could start with 3, but
yeah, okay. I don't think the eggs need wings.
All right.
You know, trail eggs. You ever played Yoshi's Island?
That's right.
Okay, is there anything else for multiple lives? I think this is a great starting point. It'll make the game easier and also have this cute little egg animation, which will be fun.
I feel like we should get more lives somehow. Maybe as just you get more points or something.
Okay. What should symbolize that?
Maybe every 10 points or 20 points. I don't know.
Sure.
And the other thought is, as soon as you hatch from a new egg, maybe you should have a little pause, like so you're not immediately overwhelmed by logs and you're at some different position than you were before. Yeah.
Yeah, so that's something you'll see a lot of times in video games where you'll hit something and then maybe your sprite blinks for a little while and it makes them invincible during that time. And so this just gives the player a little time to course correct, figure out what they're doing, and get back into the game before that they do another collision. Okay, I think this is a great place to start. Yeah, let's get going. I'll keep our plan right here and head on over. So let's start by just starting with more than one life. So we're using the score blocks right now in the info category. There's actually another very useful block in here, which is the life. So if I'll drag out the set life to 3, and now I got 3 hearts up in the top of the screen.
What happens if you run into a obstacle now?
Game over.
Oh.
Yep. So we're going to have to go and remove all the game overs from our code. And because we're going to have some more behavior that we've talked about when we actually do take damage, I'm going to define a function because we have game over in a few different places in our code. And this will make it so that we have just one piece of code that handles the damage.
Makes sense.
Okay, so I'm going to create a function and call it take damage.
Sounds great.
All right. And I'll put it right next to our notes. And now let's go to everywhere in the code where we're using game over and replace it with this call to take damage.
So creating functions, it's kind of like creating your own block.
Yeah, it's exactly like that. That's a great way to think about it. So we now have this, our own block, just like the built-in blocks that we can use to encapsulate our code. All right, so let's try playing the game now. And invincible.
It's definitely easier.
Yeah, no, for sure.
So,
okay.
When we fall off the bottom of the screen, we still want to stay on screen, right? I wonder if we should, when we hit the bottom, we get a small velocity bump up or down.
We could do that. We could also just cap it.
That's true.
So let's add some logic right here in this one. First, let's make the take damage actually make you take damage. Does that sound good?
Sounds good. Yeah.
So we'll go back into the info category, and there is a changed life by -1. Wait for my code to refresh. Oh, I hit pause. And now every time I do anything that would cause me to take damage, it's just going to keep running because we don't have those invincibility frames. And it'll just deplete all of my lives right away, which is fun. Okay, so I like your idea, Daryl, of capping the or adding a plus for the velocity. Actually, I wonder if you would be able to use that to cheat by going under the gates or over the gates or something.
Oh. Well, you would still lose a life, I'm thinking. So you hit the bottom, you lose a life, and then you bounce up a little bit so that you don't just skid along the bottom and lose tons of lives. That's my thought.
Okay.
So you'd be paying a penalty, but you wouldn't immediately die again.
Okay. Let's go ahead and go into here. And we're going to have two cases for this, right? Because we're going to have it win for this case or this case.
You can maybe get away with just reversing. It's probably better to have an if statement.
Oh, reversing the velocity?
Yeah, but...
So whatever velocity you hit the top or bottom with, you'll just have that. It'll just ricochet you.
Okay, so I'm going to just duplicate this expression. If I wanted to, I could create a variable, but we're going to be making a lot of changes to this program, so let's keep the number of variables small. All variables in Blockly are global, and they're great to use, but it does mean that you end up with a lot of one-off variables that kind of make your program a mess. So I'm just going to cheat a little bit and just leave this as an expression. Okay, so if the bottom is greater than the screen height, we want our duck to go back up. So we want to set a negative velocity. So let's drag out this set block, put it right here, and we'll change Vy to -10. I don't know. See what happens. I'm going to take this out real quick, and we'll see what happens.
Maybe the same amount as a jump?
Swimming duck.
Nice.
Yeah.
Okay. So let's do the same thing for the other one, except we'll set it to +100. Actually, that might be a little rough because you also have gravity. Maybe we'll set it to 50, see what that's like.
You might not even need to set it. I don't know. Maybe try playing through and see how it feels.
I mean, we have to set it, or else you would be able to go up off the screen, right?
Yeah, but that's only if you're actively like trying, and you would die.
Actually, I think you can break through this if you just hit it really hard, really fast. No? Guess not.
I think it would be pretty tough just because we have really aggressive gravity.
Yeah.
How does it feel when you're playing it? Like it's not jarring?
No, it feels just like I'm bouncing off the top.
Okay.
I think this is a good value for at least right now, and we can kind of play around with it later.
Sounds great.
The other nice thing about setting the velocity is they need to get back towards where the gates are, so this will help them correct a little bit by giving them a bump down. All right, cool. One other thing I'm going to do right now while I'm thinking about it. So whoever wrote this game the first time, me, left the duck sprite as my sprite. I'm going to rename that variable
Thank you.
to the normal name I use for players, which is the player. And now our code might make a little more sense. All right. So do we want to do the invincibility frames next?
Yeah.
So that we don't just lose the game whenever anything happens? All right. So I've got a trick for this one. So this is a trick I learned just by doing some other games in MakeCode Arcade, and I figured out this is the best way to do invincibility frames, at least as far as I can tell. And the way that you do it is you want something to happen in a certain amount of time, right? And so we can do that by going into our sprite and setting the property lifespan. So I'm going to drag out my sprite X, I'm going to change it to the player, and I'm going to change the X property to lifespan. Joey, do you want to explain what lifespan is on the sprite?
Yeah, so lifespan will go down over time. And so if you set it at 1,000, that's going to be 1,000 milliseconds. And after 1,000 milliseconds, it will destroy that sprite.
Yes.
So
it's you might
how
go
long
like,
the sprite will
oh,
exist.
we're destroying the sprite. That sounds like a bad thing. But actually what we're going to do is we're going to destroy the sprite and immediately recreate it. And this will make it easy for us to handle the timing of our invincibility frames. So for now, let's just set it to 1 second. So that's 1,000 milliseconds. And we want to turn off all collisions while this is happening. So to do that, we go into, there's a really easy way to do that involves not setting any flags, which is to change the kind of the player. So I'm going to set the player kind from player to a new kind, and I'm going to call this someone file that bug.
Well,
we're going to set it to damaged player. Oh, whoops, can't have spaces. And now all of these events we have that say on sprite of kind overlaps and on sprite of kind player overlaps this, those won't run because we are not the player anymore. We are now a damaged player.
So why aren't we disappearing here?
Yeah, it's a good question.
Is it resetting?
Oh, there it happened.
Like each time you hit?
Yeah, I think maybe it just didn't run the first time.
Yeah, maybe the simulator didn't refresh.
It is resetting each time you take damage. Shannon was right.
Oh, yeah, you're right.
Because you're still referring to the player.
Right.
Yeah.
There's an easy way to fix that. So if we check to see if the player kind, so inside sprites, there is a get kind of player right here. And I drag out a logic block. And then inside the sprites category, I'm going to drag out a generic kind block, which is down here at the bottom. Oh, whoops. I need to put that here. And I'm going to change it to regular player. Whoops. There we go.
Nice. So now if we put that back in.
Yep. And now we need to recreate our player when it gets destroyed. So inside of this sprites category, there is an on sprite of kind destroyed of kind. Joey, are you typing?
Mm-hmm.
Yeah, could you mute yourself while you're typing? Thank you. So on destroyed sprite of kind damaged player, and then we just want to recreate the player again.
So I have a question.
Yeah.
Which is, how come there are still lives even when your player is destroyed?
So the lives don't actually refer to a particular sprite. The lives just kind of refer to the lives for the entire game. So you can destroy that sprite as many times as you want. And this is really useful if you're making a game that has like levels or something where you need to reinitialize everything every single time you go to a new location.
They're global.
Exactly. All right. So because we're going to be creating a lot of player sprites, I'm going to drag out these blocks that are creating the player, and I'm going to move them into a function. And we're going to call that function create player. Never type right when people are watching me do it. Okay. here. Try this out.
Don't we need to create
One more, I think.
Sprite?
Yes, you're correct. That's an important one. Check that out. Now we have no player. Get an error.
Oh, we need to call the function, right?
Yeah.
Yes. So our program assumes there is always a player. So when the player gets destroyed, if the player variable is not set, we're going to get an error, and that's what that orange message you saw was. So just to replay that real quick, I'll drag this out. And you'll see I get the sim error, failed cast on null. We're working to make these error messages better, everybody. But for now, that usually just means you either have a variable that's pointing to something that hasn't been defined, or, well, yeah, that's pretty much what it means. So if you ever get that message in your program, make sure that you have your blocks in the right order, and make sure that all of your variable dropdowns are pointing to the things that you think they are. That's usually what the issue is.
And you can check for the little triangle warning sign. Sometimes that'll pop up next to the block that has an error in your program.
Mm-hmm. Okay, so let's move this back in here. And we want to call this inside this onDestroyed. So we're going to call createPlayer. And let's try this out real quick. This is not going to work like we think it will, because it's going to move the sprite back up to the top every time.
Right.
Luckily, there's an easy way for us to fix that. This onDestroyed sprite takes in a local variable of the sprite that was destroyed. So there, I got an error again because I didn't change this dropdown. So I'm going to change this to the player, because after we call createPlayer, we've created a new player. And we want to set its location to the location of the sprite that just got destroyed. So let me grab this one. My sprite X, duplicate it. My sprite Y. I'm going to drag out this local variable right here. Put it in. And I'll do.
Why are they called local variables?
So this thing right here is something that only makes sense really in the context of the event. So this sprite refers to the sprite that was involved in the actual event that happened. And the reason it's local is because if I tried to use the sprite outside of our event handler right here, let's try that out real quick. I'm going to create a variable. I'll just say set my sprite to in this on game update, and I'll drag out this sprite. And it won't let me put it in there. That's because this sprite variable can only be used inside of this event. That's why we call it local.
Gotcha.
All right, and I'll get rid of this block. Oops. Cool. All right, so now we've got our invincibility frames. But it's kind of hard to tell when they start and end, right?
Mm-hmm.
So usually how you indicate this in video games, or how you indicate this in a lot of video games, is by making the sprite blink. And we can do that with another animation. So I'm going to go back up to our create player, and I'm going to create another animation real quick. So I'll duplicate this block. And what should we call this animation?
Invincible?
Yeah.
Sounds good. And let's add some frames. So one frame will just be our normal duck. And then the other frame, I'm going to go in and I'm going to mess with the colors.
Awesome.
What's the opposite of yellow?
Purple?
I didn't actually know the answer.
Yeah.
I think it's purple.
Green and red, purple, orange, blue, and yellow.
Yeah. Well, anyway, I'm just going to do something that kind of looks like I'm inverting all of the colors. And we'll see how it looks in the actual game. I think it'll look okay.
Yeah.
Nice.
And I'll leave the outline intact just to
Sure.
give it some visual distinction.
Looks like a pretty scary duck.
Yep. And now, just like we attached the animation to the My Player sprite, we want to attach this one as well. So one thing you'll notice here is that I'm reusing the anim variable. That was just to make it easier to duplicate things. We don't need to keep a reference to this once we're done with this function, so it works out. All right, so now we've defined our animation. Let's go ahead and activate it. So where is our take damage function? Right here. I'll go into the animation category. And I'm going to drag out this activate animation. Change the variable dropdown to be the player. And we want to do the animation invincible. So let's see what happens.
Maybe the animation should last longer.
So what's happening is that we are still activating the animation right here.
Oh, anytime you flap.
Yep. So I'll drag this out. So we already have this checked to see if the player kind equals player. I'll just change this logic to take an and then we can test both of these. Now our animation should keep playing. Well, it doesn't look great, but it gets the point across.
I think maybe we need to be invincible for like a little bit more.
Yeah. Want to double it?
Yeah, go for it.
Maybe even longer. I don't know.
Can we spread out the logs a little bit more?
Are we? It also resets when you hit up, right, to flap.
Oh yes, you're right. I'll drag out my check again. And we'll let the player flap so that they can kind of, it'll still work, so that they can kind of reposition themselves while they're invincible, but we'll just keep the animation as the invincible one.
I like it.
All right. I'm gonna make this a slightly less stroby and update the interval to be 50 milliseconds. There we go. Cool. And maybe we can go back later and make the animation a little nicer, but for now, that's good. All right, cool. So we have lives. We have the lives being decremented, and we have our invincibility frames. So let's look what's next. Do we want to start with the getting lives every 10 points before we start doing the fun stuff?
Sure.
Okay.
We might not have enough time to do the eggs in this stream anyway.
Yeah, I might have to do that next time. So let's go into where we're actually incrementing our score, and we can change the logic there so that something happens every single time we get 10 points. Where's that go?
Up. Over to the.
Oh, yeah, there it is. Okay, so how do we check if we've gotten 10 lives since last time? Any ideas?
Well, we talked about a remainder block in one of our other streams.
That's true. That is exactly the answer I wanted. So I'm going to drag out a comparison block to check if it equals something. And the remainder block is really useful for doing something every X number of steps. Because you can check to see if something's divisible by 10, and if it is divisible by 10, that means your code will run every single time you hit an increment of 10. So let me go into math and drag out our remainder block. That is right here. And what do we want to divide?
The score, right?
Right, yes, the score. So we'll do the score. We want our interval to be 10, so we'll leave it like that. And we're just going to leave it at 0. So every single time the remainder of the score divided by 10 equals 0, this is going to run. And that ends up being every 10th point that we get.
So that's like 10, 20, 30, 40, 50, right?
Exactly.
What about 0? Does it happen at the very beginning?
Yes. So I put this under the change score by 1 to prevent that. I should have explained that. If I'd put it up here, we would have a bug where I would get an extra life the first time I hit a gap. But we only want to do it every 10th life. So I'm going to put it after the change score.
Sounds great.
And I'll go back into our info category. I'll drag out a change life by, and instead of -1, we'll do +1. And let's see if I can score 10 points. Nice.
Hey.
Got an extra life. All right. See, there's a problem with this game where whenever I start playing, if I haven't lost it, I have to keep going.
Yeah, it's very addictive.
Yeah. There we go. Works on 22. All right, I'll stop.
Now you're just coasting along.
Yep.
Riding that invincibility wave.
Yeah, you don't score points when you're invincible though. So
That's good.
all right. So I mean, do we want to stop here? We're kind of getting towards the end of our time, and I don't know if we'll be able to do the hatching eggs in 10 minutes. So
Yeah, I think it's a good spot. It's a good cliffhanger too. If you want to figure out how to make little eggs follow your characters, then tune in next time.
All right. Well, I'll share this game on the stream. I mean, on our forum, so that everyone can play it. It'll also be in the description of the video when we upload this to YouTube. And let's briefly just go over what we went through today. So we first went through the code for Falling Duck. We then kind of came up with our idea for our first kind of hack, adding multiple lives. And we've implemented a few of these, and I'm just going to mark off the ones we implemented. Start with more than one life. Done. Hatch when you collide. Nope. Hit lives every 10 points. Done. And Invincibility Frames after collision. Done.
Yeah.
And so next time we will be doing the hatch when you collide and the eggs follow you. And so we're going to keep working on this game for the rest of this week, I think. And we're just going to keep adding things to it until it becomes an awesome monstrosity of many different game mechanics.
Sounds
and
great.
we'll kind of share it at the end. But we're trying to kind of just illustrate that you don't have to build one of the games that's in one of our tutorials. You can use that as a jumping off point and really make it into your own thing. Add a lot of mechanics and make it your own. Anyway, that's it for today. I'm Richard, at Richard on the MakeCode forum.
I'm Shannon, at Cow on the MakeCode forums.
I'm Daryl, at Darzu on the forums.
And I'm Joey, at JWonderl on the forums.
Awesome. Oh, and I almost forgot. We need to plug our game jam, which is happening right now. Go to our forum and you can find out all of the information. We have all of the rules, links to everything that you need to get started in the jam. Anyone can participate, and it's going until next Monday. So
What's
get
a
your
game
entries
jam?
Well, yep, we could define. Yeah, let's define game jam again. It's like a hackathon, but for making video games.
Okay.
And a hackathon is where you just kind of work in a certain period of time to build a piece of code that does something. Usually there's a theme. In this case, our theme is one room. So your game needs to take place in one room. You can read through the rules to kind of get that an idea. Or you could watch our stream from Friday of last week where we made a game jam game and had a lot of fun doing it. So, all right. Well, it's time to sign off. See you later.
See ya.